Hi everybody, sorry I'm not here, but I'm hoping you've had a chance to fill in these definitions for tangent, point of tangency, and common tangent in sections 10.5, which starts on page 732 in your book. There's a couple theorems that you all can go through and make sure they make sense. It just tells you like a line is tangent if and only if it's perpendicular to a radius, so any radius with any tangent. And also if two segments from the same point, so like this one from that vertex, if you draw a line tangent to the circle, those are actually going to be congruent segments. So that's some important stuff. As well as when we get to circumscribed and inscribed polygons. So remember, circumscribed means that, so we're talking about circumscribed polygons, meaning these are polygons where all of their sides are tangent to a circle, but they're on the outside of the circle. Where we talked about inscribed earlier, where the point of the polygon, the polygon's inside the circle. Well, circumscribed, they're about the circle, they're outside the circle. But all of these are points of tangency, if I could hit them right, even though I'm missing it. But those are all points of tangency, which is significant. And there's some examples of not circumscribed. But I wanted to go through a couple examples before you all did your homework from this part. So right here, we know we've got a point of tangency here, which means these are perpendicular, which creates a right triangle. So I hope you are cheering and excited that there's a right triangle. Because now all of a sudden we have these things that apply that didn't earlier. So we are working on trying to find this value of x, which if you notice is the radius. We need to find the radius of this circle. So right here, notice that's a radius, which means we know all the radii in a circle are all congruent. So we can apply Pythagorean theorem here and say x squared plus this side, which is 4 squared, equals, now notice our hypotenuse is this distance x plus 2 more. So we actually have a binomial that we need to square. So then you go through and solve. We've got x squared plus 16 equals your x squared plus 4x plus 4. I'm certain none of you put this is not equal to x squared plus 4, because I'm certain you were tempted a little bit, and I get it, but that is never true. So be mindful that if you need to, write it out as x plus 2 times x plus 2. So now we're going to collect like terms, subtract x squared from both sides, then subtract your 4, and you get 12 equals 4x, so your x is 3, whatever the units are. So your radius of that circle is just 3. And then there's another thing that you ended up talking about in this section, where the distance, so it went along with that. Let me show you real quick, sorry. With this theorem 10.11, so from any point that's tangent to a circle, those are congruent segments. Well, right now we have a circumscribed polygon with perimeter of 18. Notice that from this point, it's tangent to the circle here and here, which means if that length is x, this length is also x. Same thing here. If this length is x, this length is also x. And from this same point here to that point of tangency is 3 units. So to this point of tangency is also 3. If from here to here it's 3, then from here to that other point of tangency is 3. And then you can create the equation x plus x plus x plus x. So you get 4x plus 3 plus 3 plus 3 plus 3, which is 12, is 18. So 4x is 6. Sorry about my handwriting. X equals 3 over 2. Or on team decimal, if you must, you can say 1.5 units. So that is all you have for 10.5, but you did have a homework assignment listed right there, and then I will create a video for the next section.